Hey again, you know how it is. We're going to get through this really quickly. We're going to talk about area. Area in general is, I like to think about it like a rug, right? It's the space that is covered by a shape, okay? So we're talking about space, a two-dimensional space, right? So we've got length and width oftentimes. All right, let's go ahead and get started, beautiful people. So we've got some area formulas that we need to think about. So when we talk about a rectangle, let me get my pen. When we talk about a rectangle, we know that it's going to be length times width or base times height. I'll say base times height just for saying base times height. So base times height. When we have a square, we know that all the sides are equal. So technically we can do base times height. Sometimes you might see in textbooks side square. So let me write A. Area is equal to that. Area is equal to side square in this case. In reference to a circle, we don't have a natural, easy way to see why this is true, but a circle's area is dependent on pi and the radius. So an area of a circle would be pi r squared, okay? And that's going to be the area. When we talk about a parallelogram, and we discussed that in the last video, it is a quadrilateral, meaning a four-sided figure, similar to a rectangle, or a rectangle is included in that definition, but it also includes other slanty objects like the one you see here. When we talk about the area of a parallelogram, whether it's in this orientation or an orientation like this, right? Doesn't matter whether it's laying on its wider side. It's always going to be base times height. And the height is measured from the uppermost point to the bottommost point and straight down. So what do I mean? So I mean you would go to the tippy top and draw a straight line down. If that's the height of it, that's what you would use to do base times height. So it's similar to this. However, you don't take the height from the side necessarily. All right, so what would that look like in this case? The base would be this little side, but the height would be from the top to the bottom where the other side would be if it were extended. I know that's a little tricky, but I think that's a concept you can hold on to. So the height is not the length of the side. The height is, when we think about it, from the perpendicular distance from the height to the base. And it may hit the base or it may not, all right? Okay, and a triangle, I think most of you are very familiar with this one. Triangle is kind of like half of a rectangle, depending on how you draw it, and so, or half of a parallelogram. So if it's half, it's going to end up having a similar formula, but it'll be 1/2. So you need to know the height of your triangle, which also may not be contained within the triangle. And you also need to have the base. So here's the base of my triangle. I'm going to put my height in red, and the area of a triangle is given as 1/2 base times height. All right, so that's all we need to do or know to move forward. Let's look at this first example. It's got 4 parts to it. It says the rectangle that has a length of 7 yards and a width of 1 yard. So if the length is 7 and the width, that didn't go well. I'm going to let it go. And the width is 1 yard. The area is going to be base times height. So area is equal to base times height. The area of this rectangle is going to be it's going to be 7. 7 yards, but we say square because we're talking about how many square yards would be in that particular space that we're discussing. How about a square that has a side length of 2 meters? Yes, you got it. The area is going to be 4 meters. This is important, squared. A parallelogram that has a base of 11 feet and a height of 9 feet. So we could have a parallelogram like this. The base is 11 feet and the height is equal to 9 feet. And again, we're rocking that base times height business, and our answer is going to be 99 feet squared. All right, this last example for this problem, for this part of the example 1, a triangle with a base of 12 millimeters and a height of 5. So here's the base is 12 millimeters and the height is 5 millimeters. I think I need another M here. And I have to remember that the area is equal to 1/2 base times height. And so that's going to be 1/2 the base 12 times the height 5, which is going to end up giving me 6 times 5, which is going to end up with 30. I'm going to draw an arrow over here and put my answer and say that that's 30 millimeters squared. And those are my answers. If you have any questions about this, I know I'm moving quickly, but I think you've all seen this before. If you have any questions, please ask me in class. All right, let's take a look at example 2. Find the area of each circle to the nearest tenth. So now we're using this formula. Area is equal to pi r squared. And again, we're going to concentrate on the tenth. For my intents and purposes, we're just going to use pi is equal to 3.14. And we're going to find, so if the radius is 3 centimeters, I have this shape here. I need to figure out the area. Area is pi r squared. And so the answer to this is going to be 3.14. I'm just replacing pi with that. And the radius is 3, but 3 squared would be 9. So when I calculate that, what I'm going to get is 28.26. We were asked only to round to the nearest tenth, which is this place here. So it's 28.3. Don't forget your units, centimeters squared. Anytime we're talking about area, we're always going to say whatever the units are, and it's going to be squared. Okay? And the final one in this section is the diameter is 21 meters. So if the diameter is 21 meters, that's this. We don't have a formula that gives us, that allows us to use diameter, so we need to figure out what the radius is. We know that the diameter is twice the radius, therefore the radius is half of the diameter. The radius in this case is going to be 10.5 meters. And what we'll do now is apply exactly what we did before, pi r squared. So 3.14 times 10.5 quantity squared. And when I do, I get 346.185. Again, focusing on what we were asked for. We were asked to round to the nearest tenth. So that's 346.2 because I'm rounding up. And I'm not going to forget, we're talking about meters, so that's meters squared. Voila, that's it. I look forward to seeing you guys soon. Talk to me. Let me know how this is going. All right, bye-bye.